All right, welcome everybody, and thanks for joining in on my talk on scaling compliance in regulated environments and how you can do all that combining Octopus Deploy and NAPE. My name is Bernhard Hopfmüller. I'm with Cross. I'll talk a bit about Cross later in my talk. So for now, I want to start with something completely different. And that's the question for you out there, whether you like dogs or not. You might wonder why I'm asking that, but bear with me for a second. It will make sense. Trust me. So, regardless whether you do like dogs and maybe even have one, or you don't have a dog, you will encounter signs like that on your everyday park walk, right? You will go in the park and you will see a sign that says, "Keep your dogs under control." And if you now see a person that actually has a dog and the person who really doesn't like dogs, you will see different interpretations of that sign. A person who really doesn't like dogs or even is afraid of them will say, "Oh, great, there are no free roaming dogs here in this park, so I can just walk in there, take my run, take my stroll, and it will be safe of those vicious beasts." Until the point one of those things starts running at you and almost hits you over. And then you might, depending on the dog owner, hear a whistle, and the dog will return to his or her owner, and you will potentially get into a fight with that owner person, saying, "Hey, why don't you have your dog under control?" And that person will say, "Well, but I have it under control, right? I gave a whistle and the dog returned to me." So you can see there's sort of an ambiguity in that "keep your dog under control" sign here. It could mean that your dog is actually on a leash. It could mean that the dog is voice controlled. It could mean, hopefully not, but it could mean that the dog actually has a shock collar. Or it could mean even that the dog is in a fenced area, or 100 other interpretations you could put into that "keep your dog under control" sign. To make it even more absurd, even a sign like "keeping your dog under close control" and indicating that here with a leash leaves room for interpretation, right? Because you could say, "Okay, I'm carrying my dog even though it has a leash," if it's a very small one. You could say, "Okay, my dog is under control with a long leash, with a short leash," or "I'm a person that actually needs a guide dog, so I have my dog by me guiding me around." You can see there's a lot of room for interpretation. And you can encounter those things not only with dogs, but in your everyday life scenario. Imagine just the last conversation you had with your significant other when he or her said, she or he said, "How about you clean up the apartment," right? There's a lot of interpretation for that also happening. And there's a term coming actually from philosophy defining that thing, and it's called open texture. Open texture means there's a term to refer to the universal possibility of vagueness empirical statements, like the one with the dog under control, or the one like "our apartment should be clean." And here's another one that might maybe sound familiar to you or not, but I will just read it out. It goes like, "Financial entities shall implement the ICT business continuity policy to ensure the continuity of the financial entity's critical or important functions." Well, that says a lot of everything and a lot of nothing, right? And that actually is from the Digital Operations Resilience Act, or DORA short. And you can see that that DORA thing is, if you go back to what we defined before, a lot of open texture and a lot of not very concrete what that means. So if we look at regulations like DORA, we can say DORA is open texture. DORA describes an outcome and not an implementation. DORA will never say "add health checks for your load balancer," right? DORA will only say you need to ensure operational resilience. And it's up to you to define what it technically means. So your job is it to add texture to that thing. And depending whether you are now actually a techie or a person in higher in management, it leaves the same story, right? It's up to you to define what DORA means, and you are responsible on a different level of that. You might ask now, or have asked yourself in the past, if you had to deal with DORA, or for that matter, any other regulation, how do I do that? Well, the same way an open texture thing leaves you a billion possibilities to interpret it, there's also a billion ways to actually achieve it. But here's one that I want to show you. And that one consists of 5 steps. The first step is we identify a risk, right? The second one is we define a rule for that risk, how to deal with that. The third step is we verify whether the rule we defined is actually met. The fourth step is we evaluate the result of that verification, whether my rule is met. And the fifth step is I act upon the evaluation of the risk. And we give those 5 steps names, right? We call them risk, control standard, assurance, risk evaluation, and control procedure. I know this is, again, very open texture now for the moment, and you maybe cannot really imagine what that means on a concrete example. Don't worry, we'll get there in a second. For now, you might ask yourself, why are we even doing this, right? Why do we even need to do those 5 steps or 100 other steps you defined for yourself to fulfill that regulation? And now I spoiled it already. You might say, okay, I'm doing that because I have to, right? Because one day an auditor will show up and say, hey, how about you show me evidence you're actually doing what you're claiming you're doing, right? And nothing that sentence basically captures the essence of what an audit is. An auditor will want to see evidence that you're actually DORA compliant. Well, the difference between an audit and assurance is this one. A DORA requires you to show proof that you have operational resilience. And assurance proves with evidence that we actually do what we say. And an audit is then nothing but checking that the proof we collected already is correct. So basically, an audit is only saying, well, you have some evidence there laying around in your company. How about you show me whether your story around that checks out or not? So you should actually assure for yourself, right? You should not make assurance in order to be only DORA compliant, but you should because you probably have an intrinsic motivation to be resilient against all kinds of things. And that's why you should assure. And an audit is just somebody coming in and checking whether what you did there is good or not. And DORA demands evidence. So DORA demands that somebody is doing that audit. Having said that, let's go back to the question how we do those 5-step thing. And as I said before, we do that by defining risks. What is a risk? Well, let's take one for example. A risk could be that my deployment of my service in Kubernetes, my microservice, might fail because the service is somehow unhealthy. Why could it be unhealthy? Well, for example, because the container crashes that my service is run with. Why would my container crash? Well, potentially because the node misbehaves that the container is running on. Why would a node misbehave? Maybe because the hardware glitches underneath it. Why would hardware glitch? Well, because the electronics that are actually inside the server somehow are not perfect. Why are electronics not perfect? Well, now we are at the material level in physics. Well, because materials themselves have limits, right? The silicon part that my transistor is built of might be broken somewhere. Shit. Now I'm sorry, excuse the language, but you might say now, shit, where do I need to go with this, right? I'm defining risks and I'm not sure where I actually should stop looking for a risk because that's infinite, right? I'm starting somewhere and I'm going from the single thing to an infinite number of possibilities why a risk should be a risk or not. That's actually very similar to this analogy of turtles all the way down. I don't know if you're familiar with that one, but Hindu mythology basically says that the world is resting on the shield of a giant turtle. Okay, let's take that. Then one might ask, okay, but what is the turtle sitting on? And then people would say, okay, that turtle is sitting on another turtle. Okay, but what is that turtle sitting on? Well, that turtle is sitting on another turtle. Okay, but and so on, right? So you can see this is very similar to what we call in IT or in science infinite regress. What does that leave for me now for my problem with risks? Where do we stop looking for risks? Well, pretty easy actually. We stop looking at the point where an uncertainty no longer impacts margin. Or in other words, a risk is an uncertainty that matters, by David Hilson. Meaning, back to my deployment, I should probably make sure that my service is healthy, and I should also make sure that the node is healthy. If I'm start facing hardware issues, I should probably look into that. But most likely, I will not need to get an atomic force microscope and look at the silicon parts that my transistor is being built upon, right? Because that's not really something that matters to me. I should make sure that the things on a higher level matter, actually. That's only a short side note. Back to actually defining a risk now that we know we have to stop at some level doing that. A risk is not only a risk, but a risk actually consists of four things. We have a risk source, something that is the origin of a risk. We have a risk event, where something will actually happen. Then if that something actually happening is happening, something that might be at stake here, and we have consequences if that actually does happen. Again, very open texture. Let me put some texture to it. So a risk source might, for example, be, okay, we know there is an exploitable vulnerability in my container image, a CVE, right? A risk event would be, I'm deploying that image into my production environment. So suddenly I have a critical or high severity CVE in my production. That risk event does not mean that something will actually necessarily happen, but that risk event will give rise to the risk. The risk defined by that trident of information security, saying, if I have a CVE in production, I might have a system at risk of exposing confidential information, confidentiality. I might have my system at risk of executing actions incorrectly or being tampered with, integrity, or the thing becoming unavailable to users, CIA, right? That trident. And what's the consequence of all that? Well, to go back to DORA, we are breaching DORA Article 6, saying that we need to be resilient in terms of operational security. Okay, now we know what a risk is, and we have a concrete example for risk. Now we have to sit down and do all that for the 5 other steps I explained before. If I would do that now here together with you, we might sit here a while longer and not have time to finish the rest of the talk. And if we do that for our customers, it's usually a 2-day workshop where we explain them the whole thing. So I'm sparing you all that, and by the power of automation, I will just say one moment later, we have that picture, the whole story, right? Identifying a risk, defining a rule for it, verifying the rule is met, evaluating the result, acting on it. What does it mean in my story? We have the risk, CIA, as before, with the CVE in production. We have a control standard, so a rule how to handle that risk. That rule would say, in that case, production images must have 0 critical or high CVEs, according to DORA Article 6 and 10. The assurance procedure, how we call it, so verifying whether my rule is met or not, will actually check the CVE scan report we did, and it will prove that we actually looked into the CVE scan, right? So that we knew at the point where we were deploying that we actually have 0 CVEs in my production. Evaluating the result is actually what I already started explaining, meaning we make sure that once we go into production, we do not have any high or critical CVEs there. Otherwise, we will have failure. And the control procedure would then be, once that actually might happen, I will block my deployment, or once I realize I have something already running in production, I will trigger remediation. So make sure that this thing is no longer running in production. I hope that will now have given you some more texture on it, actually, right? So you can imagine something more concrete with it. The good news is we now know how to handle one risk for one DORA thing, say. The problem is there is more things than DORA. There is also SOC 2, there's ISO, there are internal policies. You know the story, right? There's a lot of things happening in reality. And The problem is for all those audits, we need traceable, repeatable, provable evidence. Well, the reality, sadly, sometimes is that we know an audit is coming up, so everybody is running and panning around trying to get documentation and proof for what we did over the last several years or months or whatever. And the auditor will do his field work to collect the evidence, but that's a tedious process, really. Especially if my number of deployments is really going up, right? My manual compliance capacity is actually really, really going down. That is the same story, by the way, as why we do these days automatic deployments to ensure standards, security, etc. Right? One of the reasons why such beautiful tools as Octopus Deploy really exist, because we cannot cope manually anymore with the thing we need to do here. And the same story goes for my compliance. So, meaning the actual problem is not the compliance itself. If we follow that 5-step process or any other process that we defined to make sure that we are DORA compliant, it's the problem to scale it up. And how about we then do some automation, right? As we did before in the past already with my deployments. And here comes a tool in we call NAPE, right? NAPE is doing automated assurance. NAPE is helping me to do all those things that I need to prove that I actually followed my own rules. That's where NAPE comes in. I will show you this still. This is basically the model that the creators of NAPE based the whole thing upon, right? You can see two parts of this image. Let's start at the top. The top describes things you already saw before in my 5-step process, right? We have controls and we have risks, and they correlate to each other, right? We have risks based with risk source and risk events, and we have controls to make sure we are handling those risks in some level. And as you can see indicated by the person on the right side of the picture, that's not something we can automate. We have to sit down and do the manual work of defining my risks and of defining my controls that I want to work with upon here. I also manually have to think about how I want to face those things, right? I will need to sit down and think myself on what would an insurance procedure actually look like. So how do I make sure that those things are checked, and what I need to do upon the control procedures, right? What would be actions I would have to take if my risk would happen, and so on and so on. But the good thing is, once I've thought of all that, and now we go to the bottom of the image, I can automate it. I can automate my assurance procedure using NAPE. That's the thing we will show in a second. And I can also automate control procedures, right? There is a lot of tools we can use for automating things we want to do. For example, Octopus Deploy. And for that matter, it's very important to state what actually NAPE does and what NAPE does not. NAPE does automated assurance. So NAPE proves that you actually do what you claim you do, but NAPE does not enforcement. NAPE does not enforce policies like things in the OPA universum or Caverno or anything else in that regards would do. So let me show you how NAPE actually does do that. I will switch over to my code and show you that NAPE actually is a tool we can use programmatically, right? If I wanted to do something in NAPE, I would sit down and write an assurance procedure. That assurance procedure would, for example, check that I have zero or no, that my check for 0 or no CVE scans was fine. Let's start here. Sorry, that's a better way to start. So what does NAPE need to prove that I'm actually doing the thing I'm doing? It needs evidence. What is evidence for that matter? Evidence would, for example, be that I have 0 open GitLab issues that describe open CVEs in my projects, right? So what do we need to do in order to collect that evidence? Well, we are just writing a short script here that will, as you can see here at the bottom, call the API of GitLab and just download all my issues that are open in my project, in my project code. Sorry. And the evidence would then look like this. Once I download it, I have a JSON file, and the JSON file says, okay, here's ID 745807, and that's a CVE, a medium CVE, and it describes it. And there's another CVE here somewhere, here, new medium CVE, and so on and so on. So I downloaded all my evidence. I have it laying here as a JSON file. The evidence shows what kind of CVEs I do have. Now, NAPE describes in his assurance procedure manifest what I need to do, right? I want to check there are 0 high CVEs in my production environment. And how do I do that? I'm doing a test in the activity that says CVE no high.py. As you can see, that's actually a Python script. What does that Python script do? This Python script takes the evidence we took from before and checks whether in those incidents I have open are any high-level CVEs. And it does that by a very simple Python code, goes over all that, checks in the title, basically, if there are any high-level CVEs or not. And if you go further, we can also see in my insurance procedure here that I defined where my evidence should be, right? That's in that case, that CVE scan results I do have. And once I ran NAPE, I can show you what the output would like, and that's here basically. What I get is an insurance report. And the insurance report says, okay, we ran a assurance procedure, and that's the output of it. We have one activity, we have one action that ran, we have a CVE scan, check. We don't do a CVE scan here, but we checked the output of our CVE scan and said we have 0 matching issues found. So great. My assurance report says you actually did your CVE scan with a good result. And on the bottom, we see that my test files are here and my evidence file is here as well. So that's basically what NAPE does on a CLI level. Going back to my presentation now, that's how you would call the CLI, right? First, we start the collection process. So we start the assurance session saying, okay, we want to do now that assurance procedure for CVE no high in production. That will create basically the folder structure we want. Then we will do the collecting of the real evidence by providing the file path to my actual scan result. And by the end, we will evaluate it, meaning we will write the assurance report that will do nothing but a binary pass or fail, right? It will say either it passed or it failed. Well, to be fully transparent, it can also be indecisive, right? There could be a result that says I'm not sure what's coming out, but in our case here we have a binary. We have 0 or 1. We pass it or we fail it. And then we will beautify the picture even more by saying, okay, we have automated assurance now by using my CLI tool, and now we will either block my deployment or trigger remediation. And that's where Octopus deployment comes into play, right? I don't need to justify here in that session why Octopus is great for automating all kinds of things, but I think the story becomes more complete by saying, okay, Octopus deploy is actually the thing here in charge of the control procedure. Why does the combination work so great? Well, Octopus automates the when something needs to do, and NAPE automates the proof. So together, we are actually building up a very nice scalable resilience for that fact. I want to show you all that in a demo scenario. And the demo scenario goes back to what we did before, right? We're looking at a risk event. That risk event would be that we deploy an image that contains a critical or a high severity CVE into production, and we want to deal with that. And if you've been in the session before by my colleague Dennis, this might look awfully familiar to you. So in Cross, we are living the scalability thing to the end. So we are using the same demo here because it proves actually that the two things that Dennis talked about and I talk about here are not two things that somehow are completely different, but it's different aspects of the same thing. So what do we have? We have at step 1 some code that is in a version control system, in this case GitLab. And we have Octopus deployment triggered by getting new code. At the second step, Octopus will run a CVE or GRE scan. And then after that, we will do, Octopus will run an insurance policy check. So Octopus will make sure by using NAPE that we actually did our GVE, GRC, CVE, GRE scan before, and that one actually turned out to be true. So we are not having any problems in our production environment. And how does NAPE do that? Well, it collects all kind of evidence. In our case, it collects open incidents that we might have in the GitLab project. It could be also collecting CVEs that were found directly from dependency track or any other tool for that matter. I don't know, Harbor or any other tool that would run CVE scans, Trivy, think any tool in that matter. Or it could even be Octopus, right? It could be Octopus Deploy job that produced some variables and output, and I could use that as evidence, right? The important thing is only NAPE here runs my assurance policy check to make sure that we are doing what we claimed we're doing. And then we go into the direction of deployment with step 3. But if we fail our assurance policy check, then it's upon the user to decide whether we approve our deployment or if we say, nope, we're not going further here. However, if my assurance policy checks out, and that's hopefully the default case, then we skip that step, right? We don't need to manually ensure that this is good anymore because we have NAPE being in control here and saying, all right, looks all fine, please proceed. Then we actually do the deployment into my OpenShift environment or wherever. And the last step in this demo here is that we commit the results to DevLake. Again, here the shout out to my colleague Dennis that presented just before me a session on what DevLake actually is and what DevLake does. I will not go into the details here, just so much. DevLake is a platform that actually helps you as a development team or the owner of a development team to get some metrics how you're actually performing, right? It will give you the DORA metrics, not to be confused with DORA the regulation, but DORA metrics. So how long your issues are open, how many issues you have, how long until a pull request is merged, how many open CVEs you have, how many GRC violations you have, etc., etc. So I will not show that here. And now I will actually start the video and show you that. So yes, here comes the video. So let me show you here. We are in NAPE. We have my project, and we will pause here for a second and show you the 4 deployment steps I have, right? So the first step is that we are doing, as I said before, the automated governance with NAPE, right? The next step, I will continue with the video. The next step is, oh, no, we're hanging. Okay, exactly. The next step basically shows the approval process and deployment. The third step will the actual deployment. And the last step will be to register all those metrics into my DevLake. So let's create a new release and let's try to deploy some code. We are deploying here directly to production. Of course, don't do that in the real case scenario. We're doing it here for the sake of the demo to keep it short. But you can see we are running a NAPE check, doing nothing but what I showed you before and the CLI. That will take a while now. You can see the output here of the whole thing. And if we look in the summary, we can see that my check was fine, right? We did not find any CVEs or whatever. That's why we approved or automatically the deployment already, and we deployed finally. And now we're sending over the metrics still to DevLake. So everything fine. That's the happy path to all that thing. Now, another very beautiful thing from Octopus will come into play, right? Octopus has also something like runbooks. Runbooks could be things that run on a regular base schedule. For example, my actual CVE scan could be in a runbook. So I'm continuously checking whether or not I do have CVEs in my images. That's happening here. Now triggered manually, but imagine that could be scheduled, right, on a daily or hourly base or whatever. And as you can see from the result, oops, we found CVEs. So look here in my, we'll pause here for a second. You can look here in my GitLab repository. You actually do see incidents, right? We have a bunch of CVEs found. Well, medium CVEs will always be there, but you can also see that we have a new critical CVE found that was not there before. Let me continue the video. So, yeah. So if I go back now and try to make a new release, hopefully that will fail, right? Because the NAPE assurance policy actually should not work anymore because we do have an open CVE. So we should not be allowed by our own defined policy that that thing will run production. So now let's wait again and see what our deployment does. And you can see, oops, we have a failure, right? Great, we have a failure, one failure. And if we look in the actual output, we can see even from the code we have here, let me pause here for a second also. Never mind, sorry. Yeah, thank you. Yeah, exactly, that's what I meant. So you can see here I have a failure, right? One of my checks failed, and I even have my insurance report that shows, okay, the thing ran, but there is a failure, and I even have a link here. So if I continue my video from the demo and click here on the link, I will be forwarded to exactly that issue. So now let's pause for a second and let's think about how we would deal with those. Right. It could be, for example, that a CVE scan is a false positive. So I could do something to investigate that and then realize, okay, I don't need to deal with that anymore. Or it could also be that I need to fix actually something. In either way, there would be now a process that would look into that actual CVE and find a solution for it. I'm not demoing here now how we fix the CVE. I will just assume that we now did the process of fixing that CVE and we can close the incident afterwards, right? Now we will continue with the video because you can see that I will now assign that here to me and say, okay, in that case, it was a false positive. So I will add here some notes saying, okay, the deployment is fine. There was a false positive CVE. Not really of matter to me, so I will just proceed to deployment. And you can see that we will still have the deployment continue. And in just a second, that should actually have succeeded. Wait, I think I forgot. Oh, okay. It is deploying. Just takes a while. Yes. Okay. So now you can see we deployed, right? So we closed the incident. NAPE was fine because it didn't find the CVE scan did not in the evidence there was no more open CVE in production. So NAPE's assurance policy was fine and we're good with it. So let's pause here for a second. That's the DevLake environment that I will, as I said, not go into more detail here. If you are interested, I highly recommend that you, if you didn't before attend the session, that you go and check out then the session on that. But we can see here the GUI of my DevLake environment that ingested the data. Let's continue here for a second, also the video, and then we can see that the last step of my deployment actually triggered the ingestion of data into my DevLake scenario. That also takes a while to process it into the database. And once I have that, I can go here to my several dashboards I have. This is something that's more relevant now for the DORA part. But here, let's pause here for a second. You get here now the graphical overview of what kind of CVEs we do have or not have. And we can see we do have 3 open CVEs, but none of them is high or critical anymore. And that is a great thing, right? So deployment can walk through. And I even have here with DevLake the graphical overview, what is happening. Again, check that session to get more into that. Let's continue here now, our video. And yeah, I think that's about it. So that's the demo. Let me switch back to my presentation. So what's the benefit of doing that thing in Octopus Deploy in combination with NAPE? Well, the actual benefit is that I get something like that on the right side. I mean, you saw that I actually had a YAML outcome that showed what's happening. But if I put just a bit more effort into it and a bit more automation, I can get a very nice, beautiful report that shows how my deployment at what day was good or bad, right? Just an example here on the right. And you can only go really fast in this today's world where you have something like Dora on the constant edge of being in your back, by building compliant from the start up. I don't want to use the term compliant driven development. Well, I kind of used it now, but you see where this is going, right? If you incorporate that from the beginning on, that kind of assurance reporting into your processes, you don't later have the panic coming up if an audit is approaching. Even more beautiful, if you have that kind of thing, you're 24/7 audit ready, right? That means if tomorrow somebody comes and says, hey, we are doing an audit, that's not a problem for you, because for all your 4,000 Octopus deployments you did in the past, you do have an assurance report. So you can just, if you want, print that or put it in one folder, give it to the auditor and say, here's your evidence, have fun. Have fun digging into it, and I can tell you for every tiny detail I did here that my story checks out, right? That I can prove you very, very beautiful that I'm actually doing what I'm claiming that I'm doing. Great. We have a good story here, I think. Let me just lose 2 words about the company I'm working for. Cross, we are a Croatian German BizTech consulting company. What does that mean? Well, we are not only doing all kinds of technical implementation things, but we are also asking the question, what's the added value for you into doing that? So we're trying to mix the business value of something with the newest bleeding technology at that point. And that means also if somebody comes to us and says, hey, I'm having compliance problems on the technical level because we don't know how to prove that we're actually doing what we're doing, we will try to take that story to the next level by asking, okay, have you actually considered from the top what your risks are and what your control standards are? So we can break that down from there until the very bottom into an actual technical requirement, adding texture to the thing, right? To take that up from the beginning. And our portfolio goes then really from doing strategic things by change management, innovation process, value stream management, that the kind of considerations we did now in our situation here in regards to what actual risks and control standards are, over engineering, so basically building the thing, and we go here from actually really mainframe legacy old school things, more relevant than ever, up to using all kinds of AI things and cloud things. Not losing too much time here. And also we are then helping you to put the whole thing in operation. So we have that the triangle of the whole thing here. So to sum up what I spoke about today, and to take that dog statement from the beginning, like dogs have to be under control, in summary, that means basically Dora would state your dog must be controlled. We as human beings would specify the leash. NAPE would check that we actually do use the leash, and Octopus would stop the dog from bolting. With that, thank you very much.